You're all welcome to Explicit Fees Academic. It's been quite some days since we had our first class on differentiation. So today we're going to be talking about differentiation part 2 of it. So we did much of the fundamental and some basics of differentiation, how we got about differentiation, and we find out that it was really helpful for us to understand from the basics that whenever we are having a graph and it's a straight line graph, what happens when it's a curved line, what happens there. And we've come to an understanding and to an agreement that when it's a curved line, we tend using the derivative. Why? Because at that point, assuming the curve is to go to the negative to the x-axis or to the y-axis, what happened to that function? And we've been able to explore it, and we got so much from it in our last video. But in this video, we're going to be talking about some few examples using first principle to solve differentiation. And I'm going to try as much as possible to be more concise and more precise in my class today, but to enable you to attend to other things. Okay, having said that, all right, let's jump in. We'll be looking at a couple examples, at least 2 to 3 examples using first principle, and then we also look at some tricks in solving differentiation very fast. I mean very, very fast. If you learn this trick, you're going to know so much. So let's dive in already. Let's dive in. Okay, our first example. Given that y is equal to 3x cubed plus 5, find the y, yes, that's the derivative using first principle. I believe it's quite clear. We are asked to find the y dx using first principle of differentiation. What do we do? I believe in our last class we did one example, although we ended not really quite well, but we did one example in our last class. So I'm going to jump into this example. It says given y is equal to 3x cubed plus 5, find the y dx using first principle. That's the question. We are going to find the y dx using the first principle of differentiation, not the other course. You know that there are other ways of solving it, but in this particular question, they have been precise a lot to tell us that we should use first principle. Okay, so let's solve it. It's quite very simple. Okay, let's just write let me divide the board into 2. Write the solution here. Okay, all right, the question is y is equal to 3x cubed plus 5. Now in first principle, what do we consider? As I told you earlier, that it's a function. Y and x, they are variables, so they tend to change. So what's the variable? It's a quantity that changes over time. It changes. So y changes, x also changes. So in this case, we are given y is equal to 3x cubed plus 5. So the first thing we have to consider in this case is to look at the situation whereby we know that y can change and x can change. And I've told you in our previous video, if you have not watched it, go check it out. And here are going to be having y plus del y. That's the little change in y is equal to 3. You put x plus del x. It's an increment. The meaning of this increment plus 5. This can be your equation 1. This can be your equation 2. Okay. So for now, what do we do? I told you earlier that the moment you finish here, the leftover thing is just simplification. Indices, expansion, simplification, and that's it. There's no much way. There's no complicated stuff here. It's just that the moment you are given a problem, you have been asked to find using the first principle. The first thing you have to consider, just look at the equation, look at how simple it is, and then see how to devise a mean. Whereby in the x, very simple. You ask x plus del x. If it's in a bracket, you bracket it and then you expand it. That's when we start considering using binomial theorem of expansion, of which I will not talk about that because that's a very different ballgame in maths entirely of expanding. So I'll give that to you as an example as an assignment to go and check out what's binomial expansion, how to expand functions raised to power 3, raised to power 4, raised to power 5, and so on and so forth. And you're going to appreciate that after doing that. All right, back to what we were saying. We are given this. So what do? We have to expand this into 3 places. And I did my expansion. We have Pascal's triangle, of course. We have binomial theory of expanding. So I don't know the one you will choose to use, but I believe I trust God that in our subsequent classes I will try to use to teach people binomial expansion and just the binomial expansion to really help. Yeah. Okay. That means it. Let's dive in. Now expanding this equation 2, we say expanding equation 2. How do we expand it? Very simple. We have to expand this guy in 3 places. That's also that if you don't know binomial expansion, all of that, you should try and do that. If you don't know binomial expansion, power series, it helps us to expand bigger function with bigger degree. Okay, so from the expansion, so that we will not make most times, so I have to solve it. We have y plus del y as equal to these 3 is here, x3 plus 2x squared dx plus x. Please let her go and expand it using the normal way, plus x squared del x plus 2x del x squared plus del x cubed plus 5. Please, what we've just done here is very simple. You just look at the way of how we could expand just this guy. That's this. Or which, let me do it quickly and then clean it up here. We have to expand in 3 places. So what do? We have x plus dot x. And here we're going to have, I believe it's going to be x squared plus 2 dot x plus dot x. This is expansion. If you multiply this and this, it gives us all this. So go and try it out. Expanding this in 3 places, it gives you this. Okay. Alright, let's head down to what we're doing. So this is the expansion of this guy. I was trying to say that you should learn binomial expansion because in case in real life problem you are given raised to power 4 power 5 and you have been asked to use binomial expansion, not the other technique I will show you until we finish a couple examples here. So what did you do at that extent? You have to apply your knowledge in binomial expansion and all of that is solving it. Okay. So having expanded it down, we are going to do some mathematical combination, adding and subtracting the necessary things here. So we are going to have y equal to y plus del y, the change in y is being equal to 3, which is this one outside here. Please follow me carefully. X cubed plus 2 x squared, so x plus 3x squared del x plus 3x del x squared plus del x cubed, all close bracket, plus 5. Please, we've not done anything outside the box. What we have just done here, we've just added what is here. Please, you should take this very, very well. Go and find a way to expand it. That's all we have done. We are doing here. We're just doing the basic math you've known, and then we're just trying to step it up so it will just make more sense to you. So you should go check that out later. All right, so let's forge ahead. Okay. Now what do we do now? We now subtract y from both sides. Remember, our equation is from both sides of the equation. You should find the y dx. So what do we have? We're going to have y as y plus del y, the initial one we got here, minus y. That's after expanding and adding it. That's when you apply this. Y plus del y minus y will be equal to, we're going to have 3x cubed plus, that's multiplying this inside the box, 9x squared del x plus 9x del x squared plus, okay, plus 3 del x cube plus 5 minus y. And of course, from here we can see that there are some things that are similar that we can work with, operate them or work on it. Okay, yes, we have here 3x squared, this and this and this. All right, so here goes here. And after this, what do? We are going to have the y as being equal to 3x cubed plus 9 x squared del x plus 9x del x squared plus 3 del x cubed plus 5 minus y. I believe you've copied this already, so I'm going to wipe this particular aspect. Please note what we've done here. We are giving this student the same, we should use first principle. And in our last class, I've told you and I've taught people very carefully and very well of where the first principle is coming from. And the moment you are giving the x and the y, you have to expand the x by adding it with plus the x. That's a little increment because it's a function and it changes, and the y as well, you put the little increment there. And then you now do the normal expansion of either what we've done and we've got here. When you reach here, we now subtract y from both sides. And we are going on. Please follow. I'm just gonna put this part on. Okay, so we've got it here. Now let us substitute equation 1. Substituting equation 1 into it, what do we have? If you put equation 1, our equation 1 was y equal to 3x cubed plus 5. So we want to put this where we have y, and if we do that, we are going to have the y is equal to 3x cubed plus 9x squared del x plus 9x del x squared. Please follow me, del x squared plus 3 del x cubed plus 5. Now this is the y, which is minus. So we're going to have minus, you put all these things in squared, 3x cubed plus 5. Okay, so what do we do here? We continue. Then y will be equal to 3x. The minus sign will affect everything in the bracket, making it all minus. So what are we going to add here? So we are going to have 3x cubed plus 9x squared del x plus 9x del x squared plus 3 del x cubed plus 5 minus 3x cubed minus 5. So now, as I told you earlier, that the minus will affect whatever is in the bracket. So having said that, this guy cancels here. That's collecting like terms together. Or let's take it bit by bit so that you all follow together. That's collecting like terms. Collecting like terms. We are going to have y is equal to 3x cubed minus 3x cubed minus 9x squared del x plus 9x del x squared. Let me just clean this part so that it will make more sense. I believe you've copied this already, so we are moving on. Okay, this is where we are. All right, plus 3 del x cubed plus 5 minus 5. Excellent. We are making progress over here. We are making progress. Please, If you're just joining us, you can as well just try to join us. We've not gone too far. Okay, so this and this goes. So we are left with what? Del y is equal to, okay, this is plus, sorry. We're going to have, and this cancels this. We're going to have 9x cubed squared dot x plus 9x del x squared plus 3 del s cubed. When you get here, you now say divide both sides by del x. Oh, so divide both sides by del x. We are dividing both sides by del x. So let's see what we are going to have to do that. I believe you must have figured out your answer already. You have to divide both sides by the x. So what do we have if we do that? Alright, if we divide both sides by the x, we're going to have the y dx has been equal to, if you divide here, we're going to have 9x for dx all over del x plus 9x del x squared all over del x plus 3 del x cubed all over del x. Now, if you look carefully, here goes variable, here will be left with 1. So our answer is going to be giving us 9x squared plus 9x del x plus 3 del x squared. Okay, so this is what we are going to have. I'm going to claim this. I'm taking my time to explain so that you get acquainted with it. Anywhere you find yourself, you've been asked to use first principle. The same thing that is applicable to all problems relating to differentiation. They are all simple. They follow the same method in solving them. You can check it out from our first video very, very well, how I used steps in solving them. So you can follow up the same way. So from there, what do? We now say limit. After we got here, the limit as x tends to 0, the limit as the y tends to 0, x also, the x also tends to 0. So we are going to have the y dx has been equal to 9x squared plus, here, because here is the x, so here, when the x tends to 0, here becomes 0, and here also becomes 0. Okay, are getting me? So our answer is going to be, our dy dx is going to equal to the 3x squared. And here becomes the solution using the first principle of solving problems with degree 3. So you have to use this process, but when you are given in degree 4, degree 5, degree 6, that's why I said that you have to go and review binomial theory of expansion, because that will enable you to expand it very, very fast. Here I have to use quickly the normal method of expanding to expand. Before I complete it out, I take my time to explain how I got everything up, because I want you to follow up. So here becomes our answer. So our dy dx using first principle is equal to 9x squared. Okay, so we finished solving one example. You just need solving one example. Please, I give you like 20 seconds to glance through again from the beginning of what we've done and where we've ended before we go on. So that's it. All right, let's take another example. I've told you that we're going to take a couple examples and we proceed from there. Let's take another example. You've seen how first principle is being used in solving problems. Let's see if you can hit up another example. All right, another example, example 2. Given y equal to the reciprocal of x, find the y dx using first principle. I've been asked to find the right direction first. It's very, very short and very simple. No much complication. Very precise. Please write it out so that I will start solving it. After the class, I'm going to give assignment for those that have registered for our classes. To register for class is very simple. You just send us a message via WhatsApp in our number plus 234 811 31 8968 to enroll for our academic. So after the class, I'll be dropping materials for those that have registered and assignments, and I will assess them at the end of the class. So if you're getting this video and you've not registered, it's a privilege to you getting the video because it contains a lot, and I'll be doing more videos like this to be sending across. Okay, back to our example. We are given this. So our y is equal to 1 over x. That's our equation 1. Equation 2, I told you earlier what to do whenever you are given this. You have to add up y plus del y is equal to 1 over x plus del x. This comes to our equation 2. So from this, what do you do? Yes, what do you do? I'm giving you some time to process what you're going to get from here. From our previous example, I believe you have gotten 1 or 2 ideas. So I'll give you a couple 5 seconds to process our next step from here. Okay, so from here, what we do, we subtract y from both sides because here it's very plain, it's very simple. There is no matter what we are going to do here. So if you do that, we are going to have y is y plus del y minus y will be equal to 1 all over x plus del x minus y. So here and here goes. So our del y will be equal to 1 all over x plus del x minus y. Now substituting the value of y, this thing, the value of y into this equation, that's you put what y is into the equation, we're going to have del y as equal to 1 all over x plus del x minus 1 all over x. So that's what we are going to have. Alright, okay, let me just write it this other side. So you can see how simple it is because here it's just degree 1. It's not like root to the power of 3, 4. So you have to take our time to solve, and then get our solution. So just write that. I'll give you a couple time to copy that out so that we'll move on to the next thing. Okay, we'll move on to the next thing. Okay. Now what do? We divide both sides by, yes, we divide both sides, or you can make the simplification immediately from this point. What do we do here? We just normal simplification indices. Here, we know that we find the x here, which is x bracket x plus dx. So we are going to have del y as being equal to x minus x plus dx all over x plus dx. Alright, this is what we are going to have, of which if we expand this, we are going to have the y as being equal to x minus dx, because the negative sign outside will affect the sign inside the bracket. So that's why we are going to have this. So if you work with this, it will be all over x plus dx. Here goes here. So our answer is going to be the y will be equal to minus the x all over x plus the x. Yes, we're making progress here. Now what do? We divide both sides by the x. After getting to this point, we divide both sides by the x to get our answer. So if you do that, we are going to have the y dx as being equal to minus the x all over x plus this all over the x. Okay, yes. So from here, what do? Let me clean here we already finished solving it. I believe from here must have figured out your next move. All these are just indices. They are all indices. I believe at the end of the class I will summarize it. They are all indices we have just done it. The steps in solving functions using first principle differentiation. So from here we are going to the y dx will be equal to minus del x plus this one comes a the normal indices. Of course, when we have 1 over 2, 1 over 3, here will be equal to 1 over 2 times 1 over 3. That's what you get. These are solving. So that one we just applied here, and we've gotten to our answer. All right, let's go on. So this guy cancels this. So we are going to have the y, the x equal to minus 1 all over x plus the x. Of course, if you multiply it all, we are going to have 1 all over x squared, there's a minus outside here, plus x dx. So now finding the limit as x tends to 0, our dy dx becomes minus 1 all over x squared. Because it becomes 0. Why? Because there's a del function there. So that becomes our answer. So our answer in this place becomes our dy dx becomes minus 1 over x squared. Please write that down. I'll use a test to copy. Please write that down. It's very, very simple. You just finish the second example. Using first principle. Yeah, we just finished the first example. And it's quite very simple and interesting. Okay, so that's what we get. Yeah. We are catching up. Okay, we are making progress. Let's move on. Let's take another example and then we at least close for this part of the differentiation. All right. The last example I'll be taking on this first principle before we progress, because we have been so much to do, so we will not sleep on this first principle. I believe that with these few examples I've given, you should be able to apply them to solve other examples on your own. So we're going to just progress and move on. Okay. So we're ready to progress and move on. All right. Let's take one more example. Okay, we are given the 3. If y is equal to x squared plus 3x, find the y, the x, using first principle. We have to find the y, the x using first principle. We have been given two functions in this place, and the question here is using first principle, find the y, the x. I believe in just 3 seconds you must have just solving already in your notes and your raw book, so it won't give you much time resolving it. So we're just going to process from there. All right, we are giving y is equal to x squared plus 3x, and the question is find the y, the x using first principle. As I said earlier, the first thing you have to do is write out the equation. The function y is equal to x squared plus 3x. This becomes our equation 1. So from here, we take our next step. Y plus del y, the increment in y, is equal to x plus del x squared plus 3 x plus del x. Okay, and this becomes our equation 2. So from here we say expanding y plus del y is equal to x squared plus, if you expand it, you are going to have 2x del x plus del x squared plus 3x plus 3 del x. This is the expansion. It's very simple. I'm making it look, that's the first thing you have to expand it, of course. This is degree 2. We get this. So what do we do from here? We now subtract y from both sides. When we do that, we are going to have subtract y from both sides. We are going to have y plus del y minus y is equal to, we're going to have the x squared plus 2x del x plus del x squared plus 3x plus 3 del x minus y. So from here, we see that y cancels y, and we're left with del y is equal to x squared plus 2x del x plus del x squared plus 3x plus 3 del x minus y. From here, we substitute equation 1 into this, as putting whatever y is into this. Remember, the first thing to do, you put y plus the y and x, the increment in x, the increment in y. After that, you process by expanding the equation. You expand it using any method you want to use. After the expansion, that's when you now progress in using in subtracting y from both sides, so that the y will go off and there will be y here, so you can substitute this. It's a little mathematical manipulation, but quite very simple. Okay, now putting it, although I'm not writing it out in this example, putting what we have here into this, we are going to have the y has been equal to x squared plus 2x del x plus del x squared plus 3x plus 3 del x minus, we have here x squared plus 3x. Okay, we are making progress. Let me just clean this. Okay, from here we're going to get y is going to equal to x squared plus 2x del x plus the x squared plus 3x plus 3 del x minus x squared minus 3x, because the minus will affect everything in the function there. So from here, what do? We collect like terms. The y will be equal to x squared minus x squared, right, plus 2x dx plus del x squared plus 3x minus 3x plus 3 del x. So here goes here goes here. So our dx, let me wipe up this. So our dx will be equal to 2x del x plus del x squared plus 3 del x. Okay, we're making progress. So from here, what do? We finish simplifying. We now divide both sides by the x. So the y, the x will be equal to 2x, the x all over the x, plus the x squared all over the x, plus 3 the x del x. Please do what I'm pronouncing, del. Del, it's a Greek word meaning increments. It's a Greek word meaning increment. So please don't get lost what we are doing here. Okay, now we divide it. So we are going to have the y, the x will be equal to 2x plus, when this cancels, we let it. Okay, so the y, the x becomes 2x plus 3. So that's our solution for this particular problem. Please write that out. I'll give you also 10 seconds to copy that out so that we can progress in the next thing. I've been able to solve 3 problems in this class using first principle. There are a lot of complex problems I'll be solving, but for today's class, let's just stop here and then we'll move on into techniques. And we solve the 2, 3, and we call it a day for today's class. Then when we come back next time, now explore other examples. As I said earlier, if you want to enroll in our academic, don't only lecture. Here is just a class I'm doing on YouTube. The other classes I host on Zoom, on Google Meet, on WhatsApp. For those that have enrolled for the class, that have registered for each courses, we are having math, we are having other advanced courses, quantum mechanics. We also offer quantum mechanics. We offer quantum physics. We offer thermal physics. We offer electromagnetism. All undergraduate course. We offer them. So do all to message us on anywhere. Maybe if you're on Facebook, you can search for our academic, the Explicit Physics Academic. If you're on Instagram, you can search our name there as well, Explicit Physics Academic. And if you are on YouTube, of course, this YouTube you are using, of course, you have seen our name there. You can search for us anywhere. We are legit, we are everywhere. Message us, we always give you a reply. Okay, I believe you copied this. Let's look at something else before we close, at least in the next 10 to 20 minutes, rounding up the class. All right. Okay, so in general, please pay attention to this. I'm going to summarize everything on now. In general, when you are given a problem, what do? You are given an objective problem in an exam. You cannot apply first principle in solving long and lengthy degrees of functions in an exam where there is no time. And the exam is an objective exam, so you can just see an answer there using a short technique. So I'm going to show you a little trick in solving math, like differentiation. Very, very fast. Like in 3 seconds, you just look at the problem, give your answer. Very simple. Look at the problem and give your answer. This is look and give answer only. That no matter how the question is more complex, you look at it, give you an answer to it immediately, because this trick is what mathematicians and other people are using in calculus. So let's dive in. Yep. You're there. So now in general, can I write that out? Okay. So in general, okay, if y is equal to xn, the x will be equal to nx n minus 1. That's if you are given a function as such, what you have to do, I will explain it very well, is to take the power, the degree, down, and now subtract the degree. Okay? That's if you are having y equal to x, it's a variable, of course, raised to any power, say, let's say there is a constant a, and x raised to any power, say n. Then our dy dx will be equal to na xn minus 1, where a is a constant. I'm going to explain this. I've just said this short for. Let's say we are given y equal to, it's an example, equal to x cubed. Of course, if you want to use first principle, it may take you up to 5 minutes solving it, especially if you're just starting. But the reason why we always start with the first principle is to build your knowledge in calculus. Not only the trick and not only you solving it very fast, but to build it up in calculus. That's why we're always starting with first principle. So we just finished first principle. We are now giving this problem I want to use in general, like generalizing how do we solve it very, very fast. Okay. From this general formula in solving differentiation, you bring the power down. You're going to have y is going to be equal to what here? Of course, you know the answer. 3 comes down here. We have 3. Now we now subtract the power by 1. It becomes 3 minus 1. So it becomes y will be equal to 3x 2. So it becomes, so even though you go on there and solve it, you get this. Alright, let's test it. Let's do some back testing what we solved back then using this one. So I'm going to solve the 3 examples using these general tricks in solving them. I'm going to see that solve them very, very fast. So let me just clean and write the 3 examples one side and solve them very, very fast so that you will see what we are talking about. Please don't forget, anytime you are given any function, you are asked to differentiate. Remember, you look at it, you take the power down and you subtract the power. You are done with it. Take the power down, subtract the power, you are done with it. That's differentiation. You carry the power down, you subtract it, but any constant is 0. Any constant is always 0. You've already seen that. You've already seen that already. You've already seen that. Okay, let me check those examples. I'm going to solve those examples again using this trick. The first one we had was that y is equal to 3x cubed plus 5. And the second one we had was y is equal to this, and the third one was y being equal to x squared plus 3x. Okay, this is what we are given. So how do we use this principle? This short trick I just explained to you a couple minutes ago to solving it. Of course, I've told you the first thing I have to do, you take the power down, and differentiating a constant is 0. I hope I wrote that somewhere so that you take down the notes. Okay, sorry. Please write it down before you copy this. If y is equal to k, where k is a constant, then dy x is equals to 0. Please forgive the marker. Let me use the red one. Then the x is equal to 0. That's if you are given a problem, a constant, say 2, 3, 4, 5, any number is always 0 differentiation. But in integration, it's always x. But you see that very, very soon. But for now, let's just concentrate on the differentiation. We still have a long way to go before we enter integration. Okay, having said that, let's solve these 3 problems using the short trick. Remember the short trick. The first one is y is equal to, let's say, x to the power of n. The x will be equal to n x n minus 1. But when there is y is equal to let's say a number in front a, here the x will be equal to a n x n minus 1. Let's apply the answer what we are going to have. So we are going to have the y, the x is going to be equal to 3. This 3 comes down times 3 x 3 minus 1 plus 0. Of course, the differentiating constant is always 0. This is short trick in solving differentiation. Now, what do? We now multiply. Here, 3 times 3 is what? 9x. 3 minus 1 is what? 2. You get here 2. And our answer becomes, so 9x squared. Now, check what we solved initially using first principle. You see that it tallies with what we just got in here. Okay, let's progress. Let's move on. Let's move on. Alright, let's solve the second one. The second one is y is equal to 1 over x. How do we solve it? Very simple. You cannot go on to something like this. You have to apply some mathematical study. So the x will be equal to, this thing is the same as you said, x to the power of minus 1. It's the same thing. Please note that it's the same thing. There's no magic here. So what do we do here? We're going to put the minus 1 in front. So we're going to have minus 1. Since the minus 1 is the power down, x minus 1 minus 1, because definitely I will subtract 1 from it. So we're going to have minus, because 1. So 1 becomes insignificant. So we're going to have minus x minus 2. And when you do this, what are we going to have? We are going to have either this minus 1 over x squared. Now check the problem we solved initially. You see that the tally here. This is something I should say it like this. So check very well. I'm not fast. I'm taking my time to solve so that you understand what we are doing here. All right, let's solve the last one we did. Now problems there. Okay, our y is equals to x squared plus 3x. So the y, the x, using the trick, the short one, we are going to, here comes down. We're going to have 2x. Here it comes down. The 2 comes down here. And 2 minus 1 plus 3. Here they see 1. They are not seen. So the 1 comes down, the same thing, but 1. X. 1 minus 1. So if you play with this, you are going to have 2x. 2 minus 1 is what? 1. So 1 is here always here, but we always remove it. Plus here becomes 3. 1 minus 1 is 0. And any variable with the power of 0 is always 1. So we are going to have this. Now check the problem is solved. See that this thing tallies with what we just done there. I hope it's not making more sense now. Okay, now let's solve polynomial problems. Let's just solve 2. And we call it a day. Yeah. Let's just solve 2 or 3. Okay, let's solve something that is different from this so that we'll understand it more better. Okay. Now we are now given. It said that if y is equal to x cubed plus 5x squared minus 4x plus 2, differentiate with respect to x. This is very, very simple. This should not take you up to 2 minutes. Nope, it should not take you up to that amount. 2 minutes is too much. 1 minute. Okay, here is 3. So what do we do? The y, the x will be equal to 3x, of course. This 3 comes down. 3 minus 1 plus 5. These 2 times 2 here. X with the power of 2 minus 1. Minus 4. There is 1 here comes down, but it's not always important. Let me just put so that you understand it better. X 1 minus 1. And here becomes 0 because any constant, the relative 0 becomes 2. Becomes 0. Any constant. So here our answer becomes 3. 3 minus 1 is what? 2. Or 2 plus 5 times 2 is 10. 2 minus 1 is what? 1. So we remove it. Minus 4. Anything power 0 is 1. Answer becomes 4. So this becomes our answer. Very short. Very, very short. The third one. So the fourth example. So we're going to consider is y is equal to x4 plus 6x minus 4x squared plus 7x minus 2. Okay, very simple. Let's still use the same method. It says dx dy. Okay, this question says that we should find dy dx at x equal to 2. That's after solving to this extent. You put 2 anywhere you find x. At x equal to 2, what will be the equation? What will be the equation as x equals to 2? Let's solve it up here. Our dy dx will be equal to, the 4 comes down, you shall 4, the power comes down, and then you take it by 1, 4 minus 1, plus 6 times this 3, x, 3 minus 1, minus 4, this 2 comes down times 2, x, 2 minus 1, plus 7, there's already 1 here up, x, 1 minus 1, here becomes 0, of course. So when we multiply, we're going to have 4x power 3 plus 18 x power 2 minus 8x power 1 plus 7. Now they say at x equal to 2, what becomes that function? At x equal to 2, saying that you should put here 2. So you're going to have 4 into 2 cubed plus 18, 2 squared minus 8 times 2 plus 7. So we're going to have the 8 times 4. 8 times 4, we're going to have 32 plus 72. Here, if you square this and multiply by 18, you get 72 minus 16 plus 7. It's the same thing we are doing here. Just in case you have been asked what happens when that function is being equal to 2, when 2 is being substituted in the equation. So answer is going to be equal to 95. So I divide the x at x equal to 2 is equal to 95. Okay, I believe you are copying that out. Let me wipe it out. I'm taking one last example before we call it a day. Alright, we are given the square root of x. You have to find the y, the x. What do we do? Square root of x, I have to find the y, the x. Of course, the square root of x is the same as you said, x raised to the power of half. X to the power of half is the same thing we are doing here. So, having said that, I'm going to say square root of x is equal to x to the power of 1 over 2. If you now do this, we are going to have the y the x is going to be equal to, if you put this thing down, we're going to have 1 over 2 x, 1 over 2 minus 1, this between this is, which is equal to 1 over 2 x. You find the LCM 2, you're going to have minus 1 over 2. Now, if you now do everything here together, this thing is the answer. But it isn't that you saying 1 over 2 to the square root of x. And here becomes your final answer. Alright, so we're going to stop here for today. We've been able to talk about first principle of differentiation and we've come to an end to it. So if I'm coming back next time to touch first principle, it's just to be solving problems, different problems, complex problems that involve first principle, so that in case you see them anywhere, you will not have a problem approaching them. You're all welcome once again to Explicit Physics Academic, a home for academic excellence. It's a place whereby no matter your background in math, in physics, the moment you join us, just within the interval of 5 months, you see yourself up to speed. We don't joke with our students. Our students are all genius out there. They are all doing very, very greatly. You can go out there and check on or ask people around of Explicit Physics Academy. We give out the best to our students. So I do see you guys next time in our next class, and we're talking so much still on calculus and physics. So I will be dealing only on the calculus aspect of maths and then the physics entirely. We do much of physics. Please, if you're a physicist or engineering student, statistics, know that this video is very, very beneficial to you. Do well to hit on the subscribe button after watching, and also follow us on other social media for next content. Thank you. See you guys next time.